Hey everybody, Kit Merker from Plainsight here, and I'm joined today by our new CTO, Venky Renganathan. I think I pronounced that correctly.
Perfect.
There we go.
Yeah.
He's just joined us as our new Chief Technology Officer, and I'm very, very excited to have him here today. I thought it would be fun for us to just sit together and talk a little bit about you and the company and where we're going. How's that sound?
Yeah, perfect.
So I guess to get things going, tell us a little bit about your background and where you're coming from.
Yeah. So I spent upwards of 27 years in the business, software business. So the biggest sort of length of time I spent was in Amazon for 12 years, where I led development teams in Cellular Marketplace, the third-party marketplace platform, as well as AWS. And before that, I spent about 9 years at Microsoft, in Microsoft SQL Server, and then some in security. So a lot of software development, a lot of enterprise software development at scale, distributed systems, that kind of stuff, databases. So a lot of experience in big companies. So you get to know how to develop software, how to build products, how to build teams. But I also benefited by being in startups where, I was able to sort of 0 to 1 kind of product and 1 to end. So you get to build stuff in a different way and with a smaller set of resources, but how to optimize for best. You have a lot of ability to change the way we do stuff in startups. So I've enjoyed both sides of the equation. I love it. I just love to be in the software business. I love building products. So I'm super happy to be here.
Well, tell me more about, your background, obviously super impressive, and I think very relevant to what we're trying to do here as we're transitioning computer vision into this sort of modern software architecture, modern software infrastructure mindset. But what, maybe in your words, like what attracted you to Plainsight, and what do you see as, what we're doing that kind of fits with your mission in life?
Yeah, I loved Plainsight the first time I read about it, and after I talked to you. The cool thing is what we're trying to do to get computer vision to the regular developer. Like that's the big key for me, because back in the day, like in the 90s and even in the 2000s, like data centers and a lot of places have tried computer vision to use them, and it was super hard. Beyond you can do an alpha beta kind of a release, and after you can't go GA because it's not a mass production stuff. It was too expensive cost-wise. And also very hard to implement. You needed engineers that are very specific to computer vision. I think the cool thing we are doing here is how to bring it to the developer that is not a computer vision developer, but a regular developer can build applications based on computer vision. Reading all kinds of stuff from the camera, being able to be selectively, pick what you want to look for, and then process them, train the model, and actually get results out of it as a developer. So I think that's a big key for me.
That is exactly right. And that aligns perfectly with the vision that we're trying to build. And when you think about sort of the challenges that a regular developer has, you mentioned a little bit specialized skills, but maybe you can double click on that a little bit. What are some of the gaps in knowledge? If I want to go build a computer vision app today without Plainsight, without OpenFilter, what are some of the kind of core challenges that I would run into as a first timer? What do you think?
I think there's no ready-made objects or like functions they can leverage. Like for example, OpenFilter is an example. Like for example, I can use a specific filter to read a license plate or some sort of an OCR stuff. So there's no ready-made system like that. So everybody has to build their own, and you have to build it in a sort of a non-cloud architecture, a lot of on-prem kind of stuff. Mm-hmm. So a lot of code, a lot of development that needs to be happening. And then you also create a lot of custom code that's not used by somebody else. So I think the key is to be able to, it's like a menu. You have a menu of things that you can grab from this, our infrastructure, and then you build your own application based on that. I think that's the coolest part about bringing it to the regular developer with using the modern architecture. For example, you could be in the AWS cloud, and you could use all this systems, and you can leverage, how you use your server, how you use your GPUs. You can monitor all those in the cloud architecture. That's the modern way of doing it. And I think that not much focus may have happened in that situation.
One of the questions that we get on the technology level from customers a lot is, well, why can't I just use ChatGPT? Why can I not just use Amazon SageMaker? Why do we need another set of tools for AI, for computer vision, in order to make it scale? Why can I not just leverage that? And I have my own opinion on this. I'm curious to hear your take on this, or how we're approaching this problem.
I think it's so there's a difference between doing it for fun, I think, or doing it casually versus putting something into production that's repeatable, and you're able to consistently train the model to really get you better results. I think it's the consistency, the back-end specialized code that we need in order to build those filters, and being able to be repeatable. I think that's a big key. I think it's not a hobby, or it's not something that you try and then it has to be in production, in enterprises where they're doing serious work across hundreds of stores or hundreds of establishments in terms of how to get it into production. Also have this a regulated production environment where it actually, what do you send to the cloud versus what's on-prem? You all get to organize all those data, and also let's not forget the UI. Having that consistent UI so people can actually visualize what's happening. So I think having this integrated system of filters, models, UI, and being able to have this sort of BizOps environment, the operational, building that pipeline of right from the stage where you detect something happening on the camera, how do you take it all the way to a spreadsheet or some sort of a output that we can actually see? I think in the production environment is a key. So
I agree with you. I think there's a lot of exciting features in the next release. We don't need to preview them all here. You've got a team of engineers. You've been spending time with them. Maybe share a little bit. What are your thoughts on the kind of engineering culture we're building here? We obviously are looking to grow the team, and we want to get additional engineers on your team. So for people who may be thinking about a new opportunity, what would you say about the engineering culture that we're building here at Plainsight?
One of the things, I'm a student of the game when it comes to building teams. I've spent so much time the last maybe 20 years. What I love about building teams is you build a set of complementary skill on the team, and you let them go. Back to Steve Jobs saying you hire good people because you want to let them go, kind of stuff. I think you hire the best people. You give them responsibilities and the power to determine what's the right thing to do, and then you be the sort of the guide, the person who audits or checks on stuff, but ultimately you are the person that's pushing the team to do great. I've found the best results to be when each of the team members feel that they are responsible and they own something that's very concrete, and they own the results, the outcomes that comes from that. I think if you show them the path of like, hey, you are the owner of this, go do this thing, you'll achieve some great stuff. I think when you strengthen each of the engineers, it becomes a great org. Then it's like a self-driven, self-managed kind of organization.
That's right.
That you don't have to poke around all the time. So I think building the team the right way with the right seniority, for example, you need to have a sort of senior level engineers, mid-level engineers, junior level engineers. There's a growth path for all of them.
That's right.
But building that org to be a very strong, I'm very structurally mindful in that, like, you build the right structure so that the basic components and you have ownership for the basic components. And then people get to worry about integration, like between the components, who owns it, kind of thing. So I'm very high on sort of delivering results and ownership in that kind of stuff.
Yeah, well, we're right in the midst of finalizing a release right now as we're recording, and hopefully, knock on wood, we'll get it out early next week as we're planning. And there's lots of cool stuff coming in. And the other thing I would say is the diversity of skill sets on the team. We have people with great ML backgrounds, with software infrastructure background, DevOps background, UI development, full stack. It's really a strong and complementary team of people, and we do expect that as we're getting more customers and more wins, we're going to keep growing. So we look to the future. We've got I think a big, ambitious kind of high level goal around making it so that all the video can be watched by robots instead of humans, right? We have
Yes.
this big kind of dream of creating vision infrastructure for the world. But part of that is going to be informed also by the use cases and the customers. And I know, we can't really disclose customer names at this point, unfortunately. But as you've kind of started to get exposed to what you're seeing, can you tie it together? What do you see for customer use cases that you're encountering, ideas you're encountering, how we're going to bring those solutions, and then maybe paint a picture a little bit for like the long-term view? Like, what are some of the cool things you think we'll be able to do down the line?
Yeah, that's one of the attractive stuff about what we're trying to do is there are so many applicable use cases. It's amazing to me.
There's no shortage of use cases.
There's no shortage. For example, like you could think about things like just looking for a license plate on a car in a location, right? For example, it's easy to sort of quickly scan the license plate, be able to sort of like very good cameras, right? So you can detect good resolution and stuff like that, and be able to process that information without a human being being present. That's why you train the model. You sort of make sure we have the right filters to detect some specific thing about that license plate. Could be just the numbers, or it could be the state where you're from, all those things. That's one basic
thing. And in that particular use case, I think people kind of assume that is a very solved problem, but we also know, that there's a surprisingly large percentage of license plates that are being read by humans today instead of automation. So there's actually a big business opportunity there. That's a great one. What other use cases?
Oh yeah, so multiple examples. One would be sort of if you look at a catering business or some sort of a food business, right? You want to know what's on your plate. For example, it could be how amount of protein versus carb versus fiber. I want to keep track of it.
No fats on the table.
No fats
on the plate. Yeah.
Right?
Yeah.
Or it could be an absence or presence of something. Like it could be one of your chicken or some kind of protein. Is it present or not, kind of thing. And then you also have things like livestock. Like people use computer vision to detect the count of livestock. How much sheep versus how many cows versus something else. So many different applications. In the data centers in AWS, we actually tried getting cameras to detect things like oil spills on the floor, even things like cable out of place, like the cable is not connected properly. So we can detect a lot of issues through computer vision. So it saves human effort. We automatically file bugs. So if you integrate it into your Jira or whatever system, so you see the oil spill, you file the defect to the right team, and they go fix it, kind of thing. So there's numerous applications.
Yeah, that's great. And then in terms of the technology future, there's a lot going on with LLMs, VLMs. We've been experimenting quite a bit with pseudo annotation. What do you see in terms of as you think about agents and other things like that? Any previews of sort of the science fiction that you imagine once we get things going? I know we're very customer obsessed right now and focused on the immediate release. But what are you kind of dreaming about for the future?
I would say it's like I would love a situation where we're using AI to not just obviously detect something happened, but also act on it. Like, how do you turn this into an action of some sort? I think that's the future. Like a self-driven, automated application where you detect something happened. And by the way, the accuracy is the key, right? Like, did exactly the thing that we're looking for happened, or is just a spurious kind of information that didn't happen? So being able to detect very correct, that's why the training of the model is so important. And then taking actions and then being able to integrate with multiple other applications to take actions. I think that's going to be a key where it's totally, human beings are not in the process. And they're there to verify or check on things, but they're not there in the regular working of the system.
Yeah, reducing the toil, the data toil, the operational toil, that's the ultimate goal. I agree with you 100%. And the more we can be smart about it, I mean, the trade-off is always the context and the AI and the trust, right, of these AI systems. But that complementary management of these systems, I think is so critical. And as you said at the beginning, right, making it so that the average, application developer can quickly spin up a vision pipeline without having the expertise, that will, I think, be a game changer for people building those types of systems.
Yeah. One other thing I would quickly point out is the optimization of the data. Like the key is computer vision cameras in general, we have a lot of data that it generates. Over time, it adds up, right? But how are you being selective about what exactly you're looking for and having a filter like deal with that information, process it, and that's going to be the key. Like how do you save space? It's not just the space; it's also the compute. Like how much compute power do you need, the networking power we need, and all those things. So
billions of cameras generating data. There's not enough people to watch it all. So can we enlist the AI to help us? That's really the key.
Exactly.
Yeah. Well, hopefully soon after our next software release, we'll come on and do another interview like this, and we'll show some demos.
Yes.
Yeah, it'll be great.
One final thing, like we love the team here. We have a great set of people working on different aspects of the product, and we're always looking for good people.
So you can find us on plainsight.ai. Openfilter.io is our website for the OpenFilter open source project, also on GitHub. And where can people find you? On LinkedIn?
You can find me on LinkedIn, Venky Renganathan. Easy to find.
Awesome. Well, thanks a lot. Welcome to the team. Great to see you.
Thank you.
All right. And everybody out there, hopefully you enjoyed meeting Venky, and you'll see more of him. And if you're looking for help with computer vision, we're here to help. So, all right. Thanks, everybody.